right, I also want to go over your Formula Madness questions so that you can put them in, so you can start studying them. We've done these two. Let's look at those. If you want to know the length of this arc, then you multiply this angle by 2. So the answer will be 2 times the angle ADB. If you want to know this angle measure, you're going to have to take this arc and divide by 2. So we're going to go, that's going to be 1/2 arc AB. New one here. The opposite angles of an inscribed quadrilateral add up to 180. This one you have not written down yet. It's brand new, but it's very similar to the one you've already seen. Angle 1 is right here, is half of this intercepted arc. So it is half arc AC. Angle 2 is half this intercepted arc, but just to make sure, you'll want to list all 3 letters. And for room's sake, I'm going to scoot down. Equals 1/2 arc ABC. Let's move on down here. All right. We're still doing angle measures. Here we have a tangent and a secant. They intersect on the outside here. So it's going, and we have 2 arcs here. We have an arc AB and CB. What we're going to do is we are going to take half. We're going to do something to those 2. We're going to subtract them. We have to subtract the larger one. So we're going to take arc CB and subtract AB. On this one, we have 2 tangents. 2 tangents. We're looking for the measure of that angle. I want you to realize we have 2 arcs here. We have ED and we have EFD. And we're going to, again, take half. And we're going to do the same thing we did on this one over here. We're going to subtract those 2. So I will have the larger one, EFD, and I'm going to subtract ED from it. Okay. Notice that we've subtracted on these 2. And we're going to do the same thing on this one. Let me give a little bit of room here and scoot that down just a teeny bit to fit in the box. All right. We're going to do the same thing over here. I have this arc and this arc. We have 2 secants. We're going to subtract again. We're going to have 1/2. We're going to take the larger one, in this case is HI. And we're going to subtract JG. These 3 right here have tons in common. These 3, we subtracted on all of them. And we had a half in front. Similar to we having half in front on all of these. Okay. Now we're moving on from angles. We're going to go into lengths of segments. Something really cool happens on this one. We have this x and y. We're just going to multiply them together. And that equals the z and the w. On this next one, we have some segments here. We have A and C, and we have B and D. Excuse me, D. So the relationship here is the outside times the whole equals the outside times the whole. So it's going to be like this. A times A plus C equals B times B plus D. This is a similarity. On this next one, we don't have an outside and a whole. It's only that one piece, but we do have an outside and a whole. And so it's going to be outside times a whole. So our pieces are an E here, an F here, and a G, and a G here. So it goes like this. It goes the outside times the whole. And there isn't an outside and a whole here. But to help me remember, it's just E squared. It's like the thing twice, since we don't have an outside and a whole. This is our new formula. Okay? Something to memorize for your equation of a circle, it's just x squared plus y squared equals r squared, very similar to the Pythagorean theorem. This one here, we have an angle 1 on that one, and an angle 2 here. Notice the angle 1 and 2 are supplementary, but that's just a little tidbit of fun. So this angle 1 intercepts this arc and this arc. And on these, we add them. So we're going to still have that 1/2 that we had earlier up in these over here. We're going to have our 1/2. We're going to have those arcs, but these ones intersected outside. This one intersects inside. Inside's going to add. We're going to have AB plus DC. The same one works for this. We're going to have this arc and this arc. So we're going to have a 1/2, and we're going to add again, and those arcs are DB and CA. Let's give a little bit of room here. That was DB plus CA. Okay. Scoot that down around so we have room here. So you can see it well. Last one, we already covered it. Covered this at the beginning. If we have two secants and we're looking for the, we're talking about what's congruent here, these, excuse me, not two secants, I'm sorry, so two tangents. These lengths are congruent, and you can just mark them as such instead of writing the congruent. Okay, these are the answers for your Formula Madness. I hope this has helped.